Um, hi everyone. Sorry for the delay. So I think we have four topics today, and I think first one is on the BFT. Barang, you want to go ahead and share your screen?
Yeah, sure. Yeah, thank you, Tejaswi. Yeah, let me share that. Second, let me share this. Can you guys see my sharing
Yeah.
application? Okay, thank you. It's good. Yeah, hello everyone. So this PR is try to introduce the new attribute for BFD. When create the BFD session, we want to provide the next hop ID to the BFD session, and also a flag to use to indicate this session use next hop. I have a let me see this one. Okay, the purpose for this is to yeah, I have a document here. I created a PR for the to explain the motivation why we do this. So let's go through this use case. So basically, we are facing the problem is that create BFD over a bundle. Yeah, let's say at the bottom we have a pod channel with a multiple member, and we want to create a BFD session, the single hop BFD session to bind to this pod channel. Okay, a few things here. So initially, the existing one also has a user MAC address, interface name to do that. But that one will cause, because it's directly construct layer 2 package. That's one will pick one of the pod channel member. And what we want to do is that if the pod channel is done, is the pod channel status is done, so we want to block the BFD session, so the application will know that pod channel is not working. But if the system construct a layer 2 packet directly and send it to one of the member, so if the other member done, when there's a minimum link setting, even the pod channel is done, so the BFD packet can still get through and not able to detect the pod channel status down. So from the diagram here, we want to create use the point, the next hop. You can see it's pretty much layered application. And okay, I use Sonic as an example here. Okay, to the create BFD session, and the BFD session point to a next hop. So below the next hop, it can be a normal interface or a pod channel. It does not matter. If we introduce this attribute, so the system will check the next hop first, regardless the physical port is a pod channel or a normal interface. So with this one, if pod channel is done, next hop become not available. So BFD session can be done because the packet cannot be sent out. So that's motivation and the use case we are facing today. Yeah, I have a detailed explanation for how to use this this new added attribute, and there's example in the Sonic use case, and also we did some prototyping and verified how it works with the rest of the system. So any questions for this new introduced attribute?
I didn't follow. How do you select the exact member link? The application needed is you need to send some BFD packets on Ethernet 01 and some packets on Ethernet 04.
From the application point of view, the single hop BFD session is only care about the neighbor, right? If I can reach my neighbor, it does not care about which member you are using. So for the system, it's a layered system. If you use a port channel, it's depends on hardware, not hardware. It's depends on the rest of the system how to choose which member to send the packet. So the BFD itself, it does not care about that. It only care about if if I can reach my neighbor, my next hop.
Just trying to understand, Parang. For example, let's say Ethernet 04 is down and Ethernet 01 is up.
Yeah.
And by chance, the BFD packets go on Ethernet 01. The real data packets or the route rotations, right? They go to Ethernet 04. Then we
So,
have a problem here.
Okay, the thing is that with the port channel, we have a minimum link configuration, right? If let's say if minimum link is 1, so if one member is up, another member is down, right? And the whole port channel is still up, right? So in that case, it depends on the lower level protocol to how to let's say packet come here, and depend on the lower level protocol how to send the packet to the other side. So it's same as the other packet. So BFD here is just a layer 3 packet, and it's depend on the either hardware or the rest of system how to decide put the packet to which member. Yeah, basically the BFD does not touch that part. But
Okay.
yeah, but without this new attribute here, and we have to use a MAC address, use interface name. So it chooses one member. But in that case, you may choose the member with a problem or without a problem. It's out of sync with other traffic.
Okay.
Yeah, that's the main point. We introduce this point and put it in the middle of between BFD session and the port channel. Let the port channel do its own work, and the BFD session only care about if I can reach the next hop.
Okay, I'm just trying to see that could be still be a problem. Just trying to understand. Let's say if Ethernet min links is 1 in this
Yeah.
example, and
Mhm.
Ethernet 04 is down, is Ethernet 04 removed from port channel A or not?
That depends on the LACP that protocol.
Yeah.
Yeah.
And typically LACP timeout will be a longer duration than the BFT timeouts, right? Especially harder offload the BFD will be at very small intervals.
Yes, yes, in that case, yes.
So I think we will be black holing traffic, even though BFD will wrongly say that link is up, and packet can still be dropped.
Yeah, if in the fast mode, it's 1 second interval, 1 second timeout.
Mm.
And
Yeah,
a complete solution could be two parts. One is the BFD over the bundle, and another protection is a macro BFD, create a BFD session per link. These two BFD work together, it can do a completed full pass quick detection. This is also under discussion here. Yeah, there's a macro BFD can protect each link to the quick detection.
okay. So what this is solving is the current proposal solves is you don't need to pick the MAC address.
Yes, exactly. Yeah, I don't need to pick a MAC address, and I don't care about how the port channel select its member. Yeah, think about like other traffic, the L3 packet comes here and rely on the lower level protocol to choose its member. So basically, in this way, the BFD packet behavior is same as the other traffic.
Okay, I think some things, Barong, what we have to do is, right, we'll have to say when use next stop is true, user should not give the source MAC address, disk MAC address, or which takes precedence, right? Today, there's existing attributes to give the source MAC address, DMAC address for
Yeah,
BFD packets. So
yeah.
which of this will be valid, which will not be valid?
So here I did a modification here because today, if lookup valid is true, it's false. Okay, let me see here. Yeah, if skip hardware lookup, it forces you provide the VI for the virtual router ID. And because if we set use next hop, we will not set the skip lookup. So it does not require you provide the MAC address.
So Byron,
Okay.
can we add the same condition on source and destination MAC also? And basically
Yeah.
say that when the hardware lookup
If
validates.
you add this one,
Similar condition, not exactly same, but
okay, there's a problem here because if you use the next hop, the destination MAC address is already in the data structure of the next hop.
Yeah, so what we are saying, Varun, that's what we are trying to say, right? So the intent is for the application, the SI implementation should go pick the next hop, whatever's the next hop object's MAC address, right? A destination MAC address should be picked from the next hop object, and user should not provide the destination MAC address in the BFD session. Otherwise, now you could have two destination MAC address, and we
Yeah,
don't know
I
which to pick.
understand your point, but in this PR, I did not block that because I don't know in the future use if there's other use case. Basically, I will try to keep the flexibility there. I did not block it.
Flexibility is fine, but what should the implementation do? What should when both are present, what should the SI implementation do?
So use a Sonic as an example here. Here, it's not it's existing code, not using the next hop here yet. So the application may check this flag, this use next hop flag, right? And if it's use next hop flag, it will try to, okay, I think I have that in the document here. Let's see. Yeah, I have a document here. So yeah, here is just an example how to use that. If user does not provide the destination MAC, it will try to use the next hop, right, to create the BFT set. If user already provide the destination MAC, it still use the way the current attribute set. So provide source MAC, destination MAC, but just not use the next hop.
But this is like one application how it's right. This is a well-behaved application. Let's say somebody creates some application on top of Psi, program Psi such that both the destination MAC address is provided and Psi BFD session at reuse next hop is set to true, and the next hop ID is provided, right? And all these three fields are passed. What should the Psi implementation do?
Psi.
So, see, what you're saying makes sense, right? Either DesMac will be given or these two will be given. All three won't be given together.
Yeah, that okay. That's in that case, it's depend on each vendor implementation for the Psi. Let me see if I have code here. I don't have a code here, but in my prototyping, I check this MAC address. I check this one and this one. Both basically I check these two to decide to use which one. For example, if user provides this attribute, I will check the MAC address. And
I'm just trying to see, is it okay to make it consistent for all the implementations? Ashutosh, what is your thoughts? Should we leave it ambiguous or should we just define it?
So yeah, what is the rest of the community things, right? I mean, Jay or I mean, ideally, we should either add the explicit attribute, or we should at least add some comment to.
Yeah, some
specify
flags.
the-
If not flags,
yeah.
at least the comments. Yeah, I think that
Yeah.
is.
So either flag or comment should work. Yeah.
Okay, maybe this way we can again discuss offline, right? And anything else is again why two attributes, Barong? Use next stop. This more semantic. Use next stop as well as next stop ID.
Use the flag is that try to keep the flexibility. The user can still how to say that? Let me see. Yeah, if I don't use that, if I use the existing flag, it kind of force the user to use one of the approach. Uses MAC address or next hop. So today I don't want to not force that because it's hard to switch between the two. You know what I mean? If I use this flag, so currently the attribute checking force user to provide a MAC address.
Okay, so we can't do a condition checking that BFD session at an next stop ID is null. So we can't do such a condition check today in the meta checks. Is that the reason?
Yeah, I try to make it the backward compatible. If user does not provide, that's user default value.
No, what I was trying to see is right. Instead of this, we can only have used this and say if the object is null, that means we'll not use next stop is false.
Okay. Sorry. Yeah, I got a point. So that's another key point is that let's see here the diagram. Okay. So in the case, because the interface, the next hop can be changed dynamically. Let's say if the peer is gone, the neighbor is gone, and the next hop become not available. In that case, we have to change the next hop ID to a null object. And the when BFT session when try to inject packet to the null object, the packet gets dropped. That's how it works. So here, the null object is meaningful. Yeah, so basically, we cannot use the null object ID
Okay.
to replace this flag.
Okay.
Yeah.
Oh, understood. So you're saying intentionally itself, all the numbers are down, you'll put a null next top. Okay, if all the next steps are okay.
Yeah, if neighbor if neighbor is solved, this is a valid next hop. If neighbor is gone, so it's become a null here. Okay, any other questions? So yeah, I have a document, so you can look at that. And the bottom is our prototyping to see how it works. If interface is done, so it's become done. And when the interface is up, neighbor solved, its session will become up. Okay. So any other questions? Yeah, if no, yeah, thank you, everyone.
So in this, can we assume that if that use next hop is set to true, then the next hop should be preferred? Like to answer basically along the same lines what Ravi was asking. If you have actually set use next hop to true, can this I implementation, and let's say you also specified the MAC address and next hop ID, then can we assume that next hop ID should be preferred here?
So, for the site implementation, I don't know. So usually, if we use hardware offload, usually that's if you specify next hop, it's usually the forwarding already did that. Choose to look up MAC address from the next hop table, right? So let's say let's still use this diagram. Let's say a BFT packet come to the forwarding engine, right? And not forwarding engine actually. When here, okay, in the hardware offload case, so we create BFT session to the hardware. Usually there's an NPU to process that. And when the NPU process that, it got the next hop ID, and the next hop table is already in the hardware, so it will look up that. So it's I keep that flexible. User can provide that, but it depends on the implementation. Usually, it gets MAC address from the next hop data structure, from the next hop table.
Okay, sure. And another thing, do we want to add a part of this, like with the SCI implementation details into your PR to the SCI repo?
I can add the example here, but because let's see, yeah, I can add a example here because each vendor
Yeah.
their own way to implement that.
No, the use case details. So I was just wondering if you can add that to the SCI repo so that it's accessible in the SCI repo.
Where should I put if I put an example code? I did not find a. Should I put this document inside the document or in a side repo?
Yeah, maybe I will point you to that later.
Yeah.
So we have a few other topics, so maybe we'll move
That's
on
a
to
good
the next
idea.
ones
So,
if there are no other questions. Yeah.
yeah.
Any other questions on this, Pia? Okay. Not thanks, Param. I think we can move on to the next topic then. Ravi.
Yeah, okay, thanks. I think we'll start with Pooja. Pooja, can you get started?
Okay, sure. Can you see my screen? So are you able to see my screen?
Yes.
Yeah.
Okay. Yeah, sure. So hello everyone. So as we all know that today in Sai Mirror, right, we support 4 types of mirror sessions: local span, remote span, enhanced remote span, and a S-flow mirror. So this proposal is basically to enhance the capabilities of the ER span mirror session. Okay. So today in industry, right, there are 3 widely used ER span types which are mentioned which are defined in the given IEFT draft. Okay, those are ER span 1, ER span 2, ER span 3. Okay, let me very brief about all 3 types. So ER span 1 is when your original mirrored packet is encapsulated with your GRE header as well as your outer L2, L3 headers. And the GRE header used on this ER span will have all first 16 bytes will be set to all 0, and your protocol type will be mentioned as your 88B. And today we support the Sai support we have for this particular ER span 1 mirror session type with incap type equal to this mirror L3 GRE tunnel. Okay, so that's so here we are adding original, we are encapsulating original mirror packet on top of GRE. Okay, so that's ER span 1. Then ER span 2 is when the extra 8 bytes of information is embedded between your GRE header and the original mirrored packet. So this 8 byte of information is it has a specific format which is nothing but your ER span 2 header. And this GRE header used with ER span 2 header with ER span 2 will have the sequence bit set to 1, and the protocol type will be 88BE. And since the sequence bit is 1, so it will have 4 bytes to have a sequence number of the mirror packet. Okay, so in total we'll have 8 bytes of GRE header and 8 bytes of ER span header, which carries the more information about the mirrored packet and the mirror session that it has attached to. Okay, so that's a brief about ER span 2, and similar line on ER span. It's nothing but the enhanced version of ER span 2, where you will have 12 bytes of extra information embedded between a GRE header and your original mirror packet. So and here this 12 bytes have some extra information about your mirror packet, like timestamp, and they have few other fields. So this 12 bytes is mandatory, or the mandatory length of the packet. So it's like fixed, this is the minimum length of the ER span 3 header, and there is a we can have an optional of 8 bytes of platform specific header that can be added here. And the GRE header which will be used here will use a protocol type to be 22EB. Okay, so as we know that Sai already supports ER span 1. So we are proposing 2 new enums with the which is where ER span type 1 specified, to use the capabilities, to add the capabilities for ER span type 2 and ER span type 3. Okay, so to further enhance this capabilities, we have come up with two new attributes also. So the first attribute is ERSpan session ID. So if you look at this ERSpan 3 and ERSpan 2 headers, right? We have this session ID. This 10 bits of session ID is a part of this GRE3 and ERSpan 2 and ERSpan 3 header. So this can be, we have given a control of this field to the SI user. So we came up with this attribute ID so that user can specify whatever the unique ID that they want to configure for a given mirror session. And this is applicable only for the mere, in ERSpan of type 2 and ERSpan type 3. Okay, so another attribute is to set or reuse the first 16-bit of a GRE header. This is valid only for ERSpan 1 type. So in ERSpan 1, as per the instruction defined in the draft, it is said that the first 16-bit is always going to be 0 in a GRE header. Okay, so to now this capability actually already being used by one of our customers, where they do not want to add any extra overhead in the mirror packet. Still, they want to pass on some information. So they are kind of repurposing this first 16-bit to add some information, which they are using in their collector side. So to give the same flexibility to the SI user, we thought of adding this new attribute, which can set this first 16 bits of the GRE header, and this is only when you have ERSpan type 1 configured. Yeah, so we have, I provided some examples, right? With this is example for how to create, ERSpan, how to use this ERSpan 2 type, where we can, so all attributes related to ERSpan will be valid, and we have to configure all of them. Encapsulation type, we will have to give it as a new encapsulation type that we have defined for ERSpan 2. We can provide a session ID, and that will be carried in the mirrored packet. Very similar for ERSpan 3, where we can use a relevant encap type, and session ID can be provided, which will be embedded into the header. And same way for GRE1, we can use this new attribute to set any value into the first 16 bits of that GRE header. Yeah, so that is all I have. So these are the two new enums and two new attribute support that we are proposing to add to enhance the capabilities of ERSpan.
So couple of comments, Pooja. First is that the sequence bit in the ERSpan 2 header format, right? That is, the bit is there, but it can be optionally set to 0 or 1. So it's up to the implementation to decide whether they will insert a sequence number or not.
Okay, so this is actually defined in the draft, right, which has defined this ERSpan, that because protocol type which is being used for ERSpan 2 and ERSpan 3 is same.
No, I know,
So
but if you go back to, like, for example, your leftmost window, right, you have the draft open, right, the draft for share.
Yeah.
If you look in the draft, you might see that the sequence number S bit is optional to be set 0 or 1, right? And it's not always set to 1.
Ashutosh, I think the other way to answer, right? I got what you're saying. It depends on the implementation.
Yeah.
But the real value meaning is, right, Ashutosh. Pooja, if you can go back to your HLD. The way it's the draft specifies it, right? Everything is same for ERSpan 1 and ERSpan 2, both the common fields, right? The reserved bits will be 0. All these fields, right? All this will be same. Protocol type is going to be the same, and version is going to be the same for ERSpan 1 and ERSpan 2. The only difference is going to be this number. What it says is, if sequence number is 0, then it's treated as year span 1. And if this bit is 1, it should be treated as year span 2.
I
So
have
if
to,
the,
I mean, I have
okay.
to sort of go back and read again on, sorry, but I've implemented in the past, and from my recall, the session ID is the big difference, because ESPN version 1 does not have session ID. So there's no way for the collector to essentially figure out easily what is the context of the packet, right? And ESPN 2 added sequence ID, session ID, which is very useful for the collector, and sequence number. But the sequence number, if I remember correctly, was optional, and some implementations added it and some did not. I mean, the field is always there in the header, but whether the sequence number is actually incremented or not is based on the S flag. So S can be 0 or 1, but I can
want to change it. Agreed. The session ID is the use case of ESPN 2, a big use case for ESPN 2 versus ESPN 1. But the question here is, right, now this is more of a question of parsing, right? Once I see this first few bits, the first few field of the packet, right, how do I know whether it's going to be ESPN 2 or ESPN 3? Yeah, that's ESPN 1 or 2. How does the implementation know that, right? That's where the draft says is that's going to be decided by this S bit. What you said, I completely agree. That's a use case, right?
I have to read again, because from this is what I remember, because a lot of implementations don't support ESPN version 1. Actually, they only support 2 and 3. And in there, the sequence was not always incremented. And that's why the S flag is there, actually. That was the original intent.
What you're saying is, you're saying you have an ESPN 2 implementation with sequence number 0.
That's a lot of implementations out there like that. Because they don't increment the sequence number. And there are some who do. So that's why the S flag is there. It's not mandatory. The S flag is not version identifier. I mean, based on the
question is, right, how would you, okay, Pooja, maybe you can try to get that, whatever the draft, there's some way, right, how it was being identified.
So it says that it is set to 1 in case of ESPN 2.
I mean, I also
So
was
that's
reading
how
it, and
we
maybe I'm
interpret it.
not read the wrong place, but I also saw it was optional somewhere. We have to go check it again, but somewhere I saw that we can do it offline too, but go back, and somewhere I saw that it says that S flag was optional in this. Oh, I was looking at the draft version 2. You're looking at draft version 3. Okay. I'll see if it changed between 2 and 3. Okay.
Okay. But somebody is right. I think one without debate is ESPN 2 and 3, what encaps to be chosen, right? Today, SAI doesn't allow that. Today we can, that's I think pretty straightforward. Today SAI is only using the first version of ESPN, where we just have the GRE header and nothing else. ESPN 2 and 3 is something, at least that is straightforward. We have to add a couple of enums to allow the user to specify ESPN 2 or 3.
Yeah, I agree. I was just wondering, can we add a flag? I mean, we will go back and check, but can we add a flag to save the S, to set the S flag also? So implementation depends on supported by implementation or not.
You can do a capability query, you can figure that out. If there's an attribute added, you can do a capability query.
Because I know for a fact that a lot of implementations don't increment the sequence number.
Maybe this we can check offline, Ashutosh, if you have a use case, right? Then we can just add one more. See what today, the way we modeled this, we have kept it all opaque to the user, all the 16 bits, right? The first 16 bits, user can come and set it as it is. And the chip, when it generates the ESPN packet header for the packet, right? It just populates whatever value the user has given. Okay.
Okay, so you have attribute for the first 16 bits. Okay, so then
but not at the granular level, like just the S bit.
No, that's fine. That I think then is good. Okay, all right. Please go ahead.
Yeah, but still, Ashutosh, if your question is you want a way for the application to figure out whether the chip can support different values, I think that might be orthogonal. We have to figure out something additional. Today, this is just an attribute that is a create and set attribute that comes from the application. There's not a way to understand whether the chip can put sequence numbers or not. My reading of it was ESPN 2 means if the ASIC supports ESPN 2, that means it has to support sequence number. And ESPN 1 means it doesn't have the sequence number.
Yeah, no, I mean, at least in reality, that's not true. And unfortunately, the draft was written, the draft you're referring to was written probably 10 years after the implementations were done. So
Okay.
it's kind of,
Maybe Ash, if you can take a
Yeah.
look and let us know, right? Then we can maybe add that extra if needed. Yeah.
sure. Okay.
If you, any other comments? Maybe Jay, anything else? Okay, if there's no any other comments, right? This we had a couple of other PRs to discuss.
Yeah, let's move on. Let's move on to the
Yeah.
next one. Yeah. Thanks. Thanks, Pooja.
Yeah,
Thanks,
thank
everyone. Thanks.
Hi everyone, this is Prashant from Aura. Are you able to see my screen?
Yes.
Okay. Hi, good evening everyone. Today we are proposing a new lag member attribute in support of weights. So what exactly this means is the NOS can program a lag member with certain weights so that that particular port can get, the traffic can be distributed more on that member port depending upon the speed and all, right? One of the parameter can be speed, which NOS can decide on providing the weights to that lag member. This will be similar to the existing ECMP weight to the members of the next stop.
Yeah, I think it's a simple one-line change. It's just like a VCP member weight. You're doing the same thing for lag member weight. Yeah. Any questions on this?
Is this like fixed member weight we add for each member in the lag?
It depends upon the NOS. Suppose the member ports of a lag have mixed ports, assume 100 gig and 400 gig. 400 gig they can provide as weights as 4, so that during hashing and right, depending upon the implementation, right, it can be selected more often than the other member.
Destiny, was that your
Okay.
question?
Yeah. Like I was just wondering if the, let's say 400 gig goes down, how the rebalancing and things like that happens. Like does the weight get rebalanced, or how does the distribution happen in that case? So if let's say you have multiple members with one with more weight and the one with more weight goes down, then does does the implementation rebalance, or how
I
does
think this
that
is
work?
completely managed with a NOS, just like weighted ECMP. The weights are managed with the application, not with the SI implementation. The SI implementation just uses what was the weight
I see.
provided to them. I think this is in all essence similar to what we do for ECMP weights today. Same thing. It's all controlled by the application, not by the SI implementation.
Okay. Got it.
Any further questions? Okay, I think we can move on right with the next topic, if no further questions.
Sure, yeah.
Yeah, okay, thanks everyone.
Yeah, hi everyone. This is Satish from Marvel. Is my screen visible?
Yes, Satish, yes.
Yeah. So today we are proposing some enhancements to the Sai hash object. So actually this object will be used for the traffic distribution at eSIMP and lag objects. So today, right? So today in Sai, we defined these three objects for a hash for the traffic distribution for IPv4 and tunnel and basics traffic. So today we create a Sai hash object with selected fields so that traffic selection happen based on the configured fields. And then those things will be mapped to these things. Similarly, we have similar attributes even for the lag also. But today, the problem with this approach, right? Whenever we use Rocky traffic, right? So all these things will use the standard header field still L4 header only. So if you see multiple Rocky streams, right? Almost all the traffics will share the same field still V4, still L4. So because of that one, right? There is a possibility of multiple streams are mapped to the same member. So that can cause the nonlinear traffic distribution. So to avoid that one, we are proposing two more fields, which is specific to the Rocky. So that by using these fields, right, since we are using the Rocky specific fields, the traffic distribution can be linearly applied across the different members. And similarly, we are proposing the few more switch attributes where we can bind the newly defined hash fields to the V4 and V6 traffic for the ESMP. Similarly for the lag. In case if these are not configured, generally switch can use its own implementation, or they can fall back to the standard existing these OIDs. So yeah, that was my proposal. So this is how we can configure these field net hash field list. And this is how we can bind it to the switch level. Whenever these are set to the null, idea is to use the existing default V4 hash OIDs. Yeah, that's all. Any questions? Hello.
Yes, Satish, I think makes sense. I'm just Ashutosh, any questions or I'm not sure who else is there.
No, I'm good.
Thanks.
Yeah, thank you. Any other question from anyone? Okay, thank you.
Okay, thanks, Satish.
Yeah, thanks.
I think there was, I don't know, let me see if Rick is still there. There was one more topic that looks like he dropped. Okay. I did not think we'll be able to fit it in today. So yeah, we'll pick it up next time then. Anyone wanted to bring up anything else? We have a few minutes left.
Is there any update on Sai version 1.16? What's the
Yeah, so
when is the branch get off?
next week is what I'm hoping to do.
Okay,
Yeah.
okay.
So can we get these PRs reviewed? So maybe Ashutosh and maybe you can help review
Yeah,
Baron's
I'll do
PR.
Baron's
Yeah.
review now. Yeah.
Okay, thank you. Yeah.
Yeah, and Ashutosh, can you sign up for any of those things we presented today?
Yeah, I will take a look at the mirror one, the ER span one.
Okay. So maybe we need reviewers for the other two ones, right? The RDMA hash fields.
Yeah, okay.
and-
I'll reach out to Jay as well. Yeah.
Thanks.
Okay. Thanks
Thank you.
everyone for joining.
Bye.
Thanks.
Thank you.
Bye.